This is more than simply an aircraft carrier. This is a war factory that floats and is fueled by nuclear energy. Every 30 seconds, a new fighter jet takes off into the skies. A whole strike package may be in the air, fully equipped, fully fueled, and ready to attack in less time than it takes to order a pizza. Today we're going to explain how the Truman can deploy planes every 30 seconds, make 120 sorties a day, protect itself from drone swarms, and keep up a steady pace of warfare against one of the region's most persistent asymmetric threats. This is not a guess. This is what engineering is. This is logistics. This is war on purpose. The nuclear heart. The real power plant of the Harry S. Truman located down below the flight deck. 2 A4W reactors that use pressurized water. More than 550 megawatts of thermal electricity are made by each reactor. To comprehend that figure, envision supplying energy to a modest metropolis. Now picture that power being made in a steel box that is buried inside a warship. Nuclear fission separates atoms in the reactor core, which releases a lot of heat. But instead of making power immediately, that heat goes into a closed-loop primary water system. This water gets almost 600 degrees Fahrenheit. But it never boils. Why? Because it is under more than 2,200 pounds of pressure per square inch. Water can stay liquid at temperatures that would typically transform it into steam right away at that pressure. This is very important. The main system must stay steady and contained. Then, the heat moves via huge steam generators, which are big shell and tube heat exchangers. There are thousands of tubes that carry the superheated primary water. A secondary water system with reduced pressure is around those tubes. The metal barrier lets heat through. The second water boils. The birth of steam. There is clean, high-pressure steam at about 600 psi that is completely isolated from the nuclear core. This steam is what keeps the carrier going. It turns turbines. It powers propulsion. And most importantly, it sends planes into the air. The steam catapult. There is controlled anarchy on the flight deck. An FA-18 Super Hornet moves forward on the ground. The deck crew connects the launch bar from the nose gear of the airplane to a shuttle system. That shuttle links to a piston inside a sealed steam cylinder that is almost 300 feet long and sits below the deck. When the shooter kneels and points forward, the valves snap open. 5,000 cubic feet of superheated steam pours into the cylinder. Between 450 and 520 psi, the pressure rises right away. That level of pressure is no joke. It has to keep inside 10 psi. Not enough pressure? The plane stalls and crashes into the ocean. Too much stress? Damage to the structure. The airframe is cracked. The possibility of death. The piston speeds up the plane from 0 to 150 knots in less than 3 seconds. The pilot's chest feels like it is being hit by almost 3 Gs. The jet is going faster than a bullet from a pistol when it leaves the deck, and before the sound goes away, the steam system starts over. The next jet takes off 30 seconds later. The Truman has 4 catapults that can launch 4 planes every 2 minutes. The carrier can launch up to 120 combat missions a day with coordinated deck choreography. The drone swarm is coming. The 16th of March, second day of ongoing strikes. Dozens of drones take off at the same time from hidden places all over western Yemen. Low height, organized, in many directions. This isn't just random harassment. This is saturation. The goal is easy. Break through the defenses of the carrier attack group. Some drones fly just 50 feet above the ocean, hoping to conceal in radar marine clutter. But the Truman can see them. This radar scans all the way around all the time. It sends beams at 24 various angles of elevation, from 0.2 degrees to more than 28 degrees. It figures out altitude, range, and bearing every 4 seconds by looking at the return timing and angle. It can keep track of more than 500 air connections at once. It can pump out up to 2.5 megawatts of power at its peak. It can find low-flying drones with radar cross-sections as small as 0.5 square meters, which is around the size of a quadcopter, up to 90 nautical miles away. But what if a drone tries to go lower? Another guardian is waiting. The radar AN-SPQ-9B. This high-resolution radar works in the X-band and updates track data every 1.7 seconds. With a beam width of only 1.1 degrees, it can tell the difference between things that are only 2 meters apart. Detection probability is over 90%, even in strong sea debris. Both radars confirm the worst within seconds. A group of drones is coming in. The Combat Direction Center comes to life. The process of classifying threats begins. And in less than 30 minutes, more than 40 planes from the Truman are in the air. But the swarm continues coming. The bomb farm, keeping the war machine well fed. There is another war going on below deck, while missiles and afterburners fly through the air above the carrier. It's not as loud, more organized, but equally as important. This is the bomb farm. The Ordnance Assembly and Handling Area is the official name for this area. It located between the island and the edge of the flight deck. This area may not look spectacular, yet it is the Truman's most powerful weapon. There are armored magazines deep below the deck. These are huge storage spaces that are strengthened and kept at a certain temperature to keep thousands of pounds of explosives safe. Orders go out right away when the Combat Information Center figures out what the next wave needs. Aviation ordnancemen go down into the magazines. They get the warheads back. Kits for guidance, tail groups, fuses, strakes. Using special pallet jacks, each part is transferred to one of 4 weapons elevators. The maximum weight that each elevator can lift is 10,000 pounds. Explosives may move from deep under the ship to the flight deck in less than 90 seconds. Teams put the weaponry together up above. For example, look at the Jibu 31 JDAM. It begins out as a regular blue 109 bomb body, which is basically a dumb bomb. After that, sailors put on a KMU 557 guidance tail kit. It's not dumb anymore. It now has GPS guidance and a circular error probability of around 13 meters, even in places where there is a lot of competition. Systems working together. It's not just the missiles that make this so amazing. It's all about integration. Heat from the reactor turns into steam. Steam turns into catapult force. The force of the catapult turns into air power. Air power turns into a tiered defense. Defense buys time. Time keeps the beat going. Tempo is what breaks the enemy. All of the systems aboard the Truman are linked. Radars send information to cooperative engagement capability, which generates a single air picture for all ships and planes. Data moves in real time. Friendly planes have digital tags on them. Weapons are put in line automatically. People check, but the system is continually doing math, and the 2 nuclear reactors are still running under it all. Quiet, stable, can't be stopped. The price of never-ending war. It costs a lot to defend like this. 8 ESSMs in 30 seconds is worth tens of millions of dollars. Each AMRAAM and Sidewinder costs hundreds of thousands to over $1 million. Jet fuel burns at an incredible rate. Precision bombs need complicated supply chains. But in naval warfare with huge stakes, cost is calculated in a different way. The missile isn't worth anything. The carrier has to live. Because a nuclear-powered supercarrier gives you strategic strength, air superiority, and political leverage, it's hard to imagine losing it. So the defenses are stacked. Not needed. Too much. The tempo never stops. As debris sinks into the Red Sea, the deck personnel start their dance again. Another FA-18 crashes into the deck, and the tailhook catches the arresting line. It rolls ahead. The refueling starts right away. Bombs are ready. Replaced missiles. After catapult launches, maintenance staff check the panels for stress cracks. The pressure of the steam is reset. The radars keep sweeping. There is no party to celebrate the win. No break. In modern naval warfare, attacks are rarely separate. A new swarm could start tomorrow, or tonight, and the Truman will be all set. Every 30 seconds, another jet can take off. The USS Truman is more than just a ship of war. It is a floating ecology of engineering, accuracy, and planned violence. From nuclear reactors that make heat in a controlled way, to steam catapults that can launch planes that weigh 60,000 pounds, Each part has a specific purpose, to show strength, without stopping. Make sure to subscribe to Navy Recon. Like the video. Turn on notifications. And stay with us for more in-depth analysis of the machines and systems shaping modern naval warfare. This is Navy Recon. See you on the next mission.